Hello, my name is Patrick. I'm a product marketing expert at Excitech, specializing in our video motion analysis line of software, ProAnalyst. In this video, I'm going to show you the basics of how to load and play a video. I will also demonstrate how to calibrate a video with ProAnalyst. After that, I will show you how filters can be used to isolate and simplify the motion within the shot and provide a good qualitative summary of the video motion. I will also perform in-depth quantitative analysis of the video using our particle tracking toolkit and output this information into a graph. A link to this video and all of the project files created during this tutorial will be included in the description below. The video we will use today features a shotgun blast hitting and permeating a solid opaque surface. It is a single video that is part of a larger series where different distances and choke values were used. The analysis performed here is used to examine how these variables affect the blast pattern. The end user is interested in monitoring for position and time to impact of various individual shot within the blast pattern. Enough talking about this video. Launch ProAnalyst and we can begin. Step 1. Play the video. ProAnalyst is built on a powerful and versatile video playback engine. It can accept virtually any common video types and allows you to edit, trim, and resave your videos in multiple formats. Let's examine how we load a video. To load a video with ProAnalyst, you can simply drag and drop the video file into the main application window. Once the video has been loaded, we can then use the play controls in the video window to play the video forwards or backwards. The green arrow represents the play progress for the video. The blue bars represent the beginning and end of the clip and can be used to shorten off the clip in the area of interest. The video playback bar is separated into two segments with the time in seconds on the top and the frame number directly below that. The playback area also shows you your current time as well as your current frame number, and it can be used to reset your frame number, jump to a specific frame, or do a skip playback, where you skip frames on the playback. Step 2. Calibrate the video. To extract information from the video, we need to calibrate the video within ProAnalyst. ProAnalyst fundamentally does not know what it is looking at. It can't tell if we are looking at a microscopic organism or the motion of stars. Calibration gives the software a sense of scale that it can then use to make precise measurements. The more accurately your video is calibrated, the more accurate the results from ProAnalyst will be. This is arguably the most important step of the capture process and something you should think of every time you set up a shot. Most videos need to be calibrated in two ways: temporally and spatially, or distance and time. We can see that this video has already been temporally calibrated. This is typically done at the time of recording and is reflected in the frames per second that the camera records. ProAnalyst automatically loads up any known information about the video and displays it in red at the top left-hand side of the video. This video was a cine file, which means that a good deal of metadata about the recording parameters has been saved within the video. In this instance, we can see that the video was recorded at 34,000 frames per second. This frame rate is what sets our time interval above the slide bar here. You can also see the frame numbering above the slide bar. This video starts at frame 109. Presumably this video was triggered at the moment the shot was fired and then trimmed after the capture to contain only the event. We therefore need to calibrate the video spatially or tell the software information about distances in the video. We're going to calibrate the 2D surface of this plane. We can see 4 calibration marks on the corners of the surface and 1 calibration mark in the center, representing the intended epicenter of the blast. Upon first look, it would appear that this video has been shot perpendicular to the camera angle. This, however, is not the case. If the camera was actually perpendicular to the image, then the gun would be shooting directly towards the camera. In this instance, the gun is slightly below and off to the side of the shot. We can tell this because of the angles over here along the side of the surface. Now this is not a problem. It just means that we need to use a perspective calibration instead of a normal calibration to compensate for this so that the software can understand the relationship between the camera and the 2D plane that it is viewing and measuring here. To calibrate the shot, click on the image calibration tool on the right hand side of the measurement window. The default calibration for ProAnalyst is a normal calibration. We will remove that by selecting it and clicking on Remove. Then we will add a perspective calibration by clicking on Perspective. We want to assign XY coordinates to all of these bow tie targets here. The surface has been calibrated with the center point being 0, 0, and all the calibration points being relative to that center point. We want to build a coordinate system outlining the 2D surface. To do this, we want to select each of the 4 calibration points on the screen and give them actual XY coordinates. Open the setting for this calibration by clicking on the wrench. We can now set our points. To do this, center the reticle over the point of interest and click. You can now zoom in using the scroll wheel of your mouse to further refine the selection. Once you're satisfied with it, click on Set Point. This point is at -15 and -36. I'm going to set this one as 0.2, and its location is at 16 and -36. Again, so I click and use my scroll wheel to zoom around. Let me come back to this point here. This will be 0.3. It is located at -15 and 24. I'm going to zoom out and get this point up over here. It's 0.4, and 0.4 is at 16 and 24. All of these units here have been measured in inches. Now if I click Apply, you will see that the 0, 0 coordinate for the XY has been moved so that it is perfectly in the center of the target. If we expand it out, we can also see the edges of our calibration system here. And we can see exactly how the shot has been tilted and how the camera is looking up on this at an angle. Step 3, Image Processing. ProAnalyst has dozens of very complex analysis tools, all with very sensitive settings to adjust, and you have likely spent a long time capturing a beautiful, visually pleasing video. ProAnalyst doesn't care about that, and ultimately the easiest and most accurate analysis comes from ugly, high-contrast shots. The image processing stage is an important step where you destroy your beautiful videos, make important decisions on what to measure, and simplify the video down to what you're interested in and what you're not interested in. Now that we have our image calibrated, we are no longer interested in our background. Let's open up image processing and remove it. To open the image processing tools, click on the image processing icon on the right-hand side of the measurement window. Let's play the video until we get to a frame with lots of shot strikes in it. The last frame works perfectly for this. With this shot, we want to remove all the background noise, and we no longer need the calibration markers. So if we can make the background black and keep the bullet strikes white, that would be great. To do this, we want to increase the contrast on the video. Click and drag the contrast slider all the way to the right. Now let's reset and replay the video. You will notice that each of the points flares bright upon impact, and in many cases gets dimmer or disappears. You can also see that the spots aren't entirely white, but have remnants of color around the edge. This is a result of the contrast that we just put on the video. We are going to fix both of these issues through image filtering. Step 4, image filtering. Image filtering is an extension of the simplification phase of image processing, but is much more intensive in nature. It can be used to display motion data, to separate similar elements, and to display information visually. Today we're going to use it to simplify our video and give us a visual overview of the event. To open the image filtering window, click on the icon on the right-hand side of the measurement window. It is directly below the icon for image processing. Click on Add. This will open a list of available features to add. The first issue we will resolve is with the additional colors in the video. We can convert this entire video to a binary black and white video with the threshold mask filter. This is located in the list of common filters. Expand the Common tab and select Threshold Binary. Click OK. This has now added a threshold filter to the image filtering list and subsequently removed all color from the image. To refine our filter, let's open up the settings for this filter by clicking on the wrench next to the added filter. Whenever a wrench appears, we have the ability to alter values within the software. When we increase the contrast in the image processing step, we ended up making much of the screen black. By default, the threshold filter divides a spectrum in half at 128, rounding all pixels brighter than that up to white and rounding all pixels darker than that down to black. We want to lower this threshold down to make darker pixels into white. To do this, let's set all the values to 1, and when you're done, click Apply. Click OK. Now let's reset our video and watch it. When we replay the video, it works well, and we see the exit points are all clearly highlighted in white. We just have the problem of the points disappearing now. To solve this problem, let's add a second filter. Before we add this filter, make sure you reset your video to the start. Click on Add. This will again open up the filter list. Expand the Common tab and select Strobe Effect. Click OK. Now when we replay the video, the exit points remain on the video and we can clearly see the blast pattern. Step 5. Analyzing. Analyzing is the point where you extract numbers from your video, where you quantify the motion within your video. It is important to understand that the results of this analysis will depend upon the work and steps you performed previous to this. We can now use this video to get more information about the position and timing of each shot. Before we do that, let's reset the video to the start, and let's reset the strobe effect by just toggling it on and off. Next, let's go into our particle tracking toolkit right here by clicking on the icon for particle tracking. We're going to enable it. Now we want to set an area of interest to avoid the noise at the top and at the edge being counted as particles. To do this, select the Use Region of Interest and let's define it. Let's define our region of interest as here. When we're done, click Set. What we have just asked the software is to find any white particles inside this region of interest. We don't care how large or how small these particles are. Now I'm going to track forward using this forward tracking play button. There we go. This allows the software to get a lot of detailed information about the size and location and the eccentricity of each of the particles as they come in, each of the individual shots. We can scroll in and we can see outlines of all of these with areas and their position. I can also output this information to a text file, an Excel file, or an Excel template down here if I want to export all this raw data. Extracting the data. Once we have analyzed our data, the final step is extracting or presenting it in a meaningful way. Let's go back into ProAnalyst and output information about the analysis. The particle tracking toolkit allows you to output individual particle information into a text or Excel file. It would output a lot of detailed information about each individual shot. Let's simplify this information and just graph more basic information about the video. So now to simplify this information, we can graph it. To graph what we've discovered here, click on the graph icon and let's add a graph line. Click on Add. The only objects that we've tracked or done any analysis on are particles. So if we expand this, we can graph the number of particles, size, angle, eccentricity, speed, or direction of these. Let's just graph the number of particles. Click OK. And this here gives us a graph showing us the number of particles over time. If I want to display a legend and refresh this graph, I can see at any point in time exactly how many particles have been counted by the software. This graph and this information can be output by right-clicking, clicking on graph menus, and exporting the displayed data. Again, this can be exported to multiple file types. I hope that was informative and helped you to understand how the analysis process worked with ProAnalyst. For more information on our software and more tutorials just like this one, please visit our website at www.excitex.com, where you can download a free trial of our software. Thank you.